Well, hello, everyone who's watching this after the fact. This is our first GRE live office hours on YouTube. My name's Andrew, and I'm excited to have you here. I think I see one person in the chat there. If you are there, if you wouldn't mind, go ahead and just type your name so I know who you are. And we'll get going. Still another 3 minutes until we officially start. So all right. So it is officially 9:45 a.m. Welcome, Brandy. Hey, how's it going? You might be the only one here today. This is the first time I'm doing these kind of live office hours, just to kind of, reach a wider audience if I can. But the idea is we're going to be going over questions today. Any particular questions that you have on the GRE or general questions as well. Thought we had someone else there. Brandy, if there are any questions that you have and that you want to go over, feel free to email them to my address. You have my address. We have someone else in the room right now too. Welcome. Again, if you're just joining, go ahead and just send any questions that you have, any GRE questions that you have, to the email address that you see on the screen there, testprepstudios@gmail.com. And we're just going to walk through them together. Just so you know, Brandy, I might say something every now and then for people watching after the fact. So even though you're the only one in the room as of now, I'll just say that. Oh, I think we have someone else there. I'm going to focus particularly on ETS official questions, right? That's the official material that you want to focus on. Manhattan, Princeton Review, Kaplan, all good. Hey, Mariella, how's it going? All good substitutes for the real thing. Nothing beats the real thing. You always want to use ETS official material to practice. And so, Mariella, if you'd like, if there's a particular GRE question that you'd like to take a look at, feel free to just shoot me an email there. Email on the screen. And we'll use today to just kind of go over some questions. Not a bad turnout. We got 4 people in the room right now. That's good. If you are just joining us, feel free to introduce yourself. Let us know if you're not one of my previous students, if you haven't taken my course yet. Let us know kind of where you are in your GRE journey. what questions you have. Today's really, the idea is going to be like an open-ended session. We'll see where things go. It's my first time doing these kind of live office hours. So again, feel free to shoot any questions you have to that email on the screen. And in the meantime, I will, here we go. Haven't had a chance to grab my test yet. Just here to listen. Great. Trying right now so I don't have my prep materials. Great. Great. Just see what these live office hours are about. Well, then I will pick a GRE question. How about that? We'll kick things off with a GRE question here. And why don't we do, this one, I'll just draw it right into the board. Again, if you're watching or just joining us, my name's Andrew. I run a GRE prep course, but the point of today is to just kind of do some practice all together here. So let's see if this works. There we go. So here's the story. ST equals the square root of 10. And this is going to be a quantitative comparison. So quantity A and quantity B. Quantity A is going to be S squared. And quantity B is going to be 10 over T squared. Bumping around a little bit. Okay, great. So again, quantitative comparison question. Now with quantitative comparison questions, as we talked about in class, right, one way that you always could go about doing this is testing numbers. Right, so we could test numbers for S and T that would give us the square root of 10. And I apologize, I see that the window is kind of bobbing up and down there. So we'll keep an eye on that. The problem, of course, here is that, right, we can't think of any numbers right off the bat for S and T that would be great. If you're very good with square roots, what you could say is the square root of 5 times the square root of 2. And that's equal to the square root of 10, right? So you could plug in the square root of 5 for S and the square root of 2 for T, and then see which one is bigger here. In this case, what do we get? If S squared, so the square root of 5 squared, that's going to be 5. And 10 over T squared, so 10 over the square root of 2 squared, or 2, it's going to be 5. Would you look at that? They're equal in this one particular case. Right? In this one particular case, they're equal to each other. Does that mean that they're always equal? Well, that's the downside of testing numbers, right? Is that when you test numbers, you always have to try a few cases just to make sure you're not missing something. So what you could do is test the square root of 1 times the square root of 10, and you'd find that it is equal again and again and again. But supposing that we wanted to do this algebraically, right? Supposing that we wanted to do the algebra of this. I'll erase this. Erase our test. Could we manipulate this equation somehow so that it looks like one or both of these? Yes, we could, right? What we could do is divide both sides by t. So when I do that, I get s equals the square root of 10 divided by t. And then square both sides. And when I do that, I get s squared on the left side and the square root of 10 squared, which is 10, over t squared. Which tells me that these two are always going to be equal. I've proven it algebraically. Right? Now, maybe seeing that algebra is not, I don't know, you think like I would never be able to do that on my own, right? Or like I could never think of that on my own. The general principle to keep in mind here is that we want to manipulate it so that it looks like the two expressions that we have, right? I could do all sorts of things algebraically if I wanted to. I could multiply, divide, right? But as far as your kind of North Star, what you're aiming for is getting the expression that you have to look like the expressions here. All right. Are there any general topics that folks are stressing about a little? Is there any particular topic on the test in general that's giving you trouble? If so, then we can definitely take a look at that. Feel free to just write that in the chat. What areas of the GRE are you struggling most with? Quantitative comparison and difficult word problems. Yeah. So with quantitative comparison, right, the name of the game, or at least the silver lining about quantitative comparison questions, as hard as they can be, is that you can always, or almost always, get yourself down to a 50-50, right? You can almost always get yourself down to a 50-50 by just testing numbers. And I think I said this in the course, like, I try to convince people as much as I can that you should love quantitative comparison questions compared to, say, multiple choice questions, because quantitative comparison questions, at the very least, you can get yourself down to a 50-50, and there are only 4 answer options. So that's what's kind of nice. And Brandy said difficult word problems. Let's see. Difficult word problems. Would this be like mixtures, Brandy, or speed? Or joint work? Are those the kind of word problems that you're thinking of? Yeah, any of those. All right, let's think of a good one here. So, and I'll just again write it on the screen here. They seem much more difficult on the test. Yeah. The good news is that so I'll say most of the word problems follow a pattern, right? If it's like a speed or a joint work or a mixture problem or a colliding trains problem, right? All of those. Every now and then, though, the test is going to throw a curveball at you. And I don't know, maybe something along the lines of, like 10 people decide to split an Airbnb and one person flakes out, right? Like, how much does each person have left? Or how much does each person now owe? And so for those word problems, there's not necessarily a formula you can follow. And in fact, and I think I said this in the course, right? The longer the description of a problem, so the longer the actual question, probably the longer it's going to take you. Doesn't mean that it's going to necessarily be difficult, but it's going to take a lot of time. So in general, I would save very long word problems for the end. But if you can recognize one of the formulaic word problems that we've talked about, so joint work, speed, mixtures, et cetera, then you know how to do those. So let's do a colliding trains problem. And so again, since these are so formulaic, I'm just going to give you the kind of parameters here. Oh, where's my, there it is. So of course the classic setup is we have train A and train B, and they are headed towards each other on one track. We'll say that train A is traveling 70 miles per hour, and train B is traveling at 30 miles per hour. So train A is traveling 7 miles per hour, train B is traveling at 30 miles an hour. We're going to say that train A train A leaves at 12 p.m., high noon. And train B leaves at 1. The trains are 270 miles apart. Trains are 270 miles apart. What time do they collide? So give this one a shot. Again, if you're just joining us or watching this after the fact, welcome. This is a GRE question office hour. And when you have an answer to this question, feel free to just type it in the chat. Total distance over total time. So that is the average speed. Total distance over total time. And that's good. It's the average speed. Here it's a constant speed. They're both going at the same speeds. So not quite total distance over total time. Let me give you a hint here. If we draw this out, right? If we draw this out, this train track, and we say that this is, what did we say, 270 miles? We can kind of track the trains on their journey. 3 p.m. Great. So, and that is the correct answer, Marielle. So, the distance between these two trains is 270 miles, right? And when you have these colliding train problems, what you want to do is kind of like move the trains piece by piece. So train A leaves the station at 12 p.m. and is traveling all by itself for an hour. And so then how far does train A get in 1 hour? How far does train A get in 1 hour if it's traveling 70 miles an hour? 70 miles, right? Meaning that when train B leaves, right, at 1 p.m., where things stand at 1 p.m., it's just kind of helpful to track things on their way. At 1 p.m., there are 200 miles left between them. Okay, so here's the trick. We don't want to think of them so much as colliding trains as we want to think of them as cooperating trains. That is, they're cooperating to cover this distance together. And the way to think about this is, in 1 hour, train A travels 70, train B travels 30, so they've shortened the distance by 100. Everyone with me on that? Cooperating trains, not colliding trains. They've shortened the distance between each other by 1 hour. Excuse me, by 100 miles in 1 hour. So you could say that their joint rate is 100 miles an hour. And that, by the way, if you notice, happens to be the sum of 70 and 30. Great. So in 1 hour, they're going to travel 100 miles. They have 200 miles to travel total, meaning that it's going to take them 2 hours to cover this distance. And of course, right, this distance is at 1 p.m., so 2 hours from 1 p.m. is going to be 3 p.m. So on these train questions, and it's rare that it'll be just as straightforward as like they leave at the same time. Usually there's a little wrench thrown into it, like this one, right, where one train leaves before the other, or maybe one train, stops and takes a break for half an hour, something like that, right? But as long as you kind of map it out, you can keep track of the two trains. Great. So we can kind of jump back and forth here between word problems and quantitative comparison, because those are the two that you both mentioned. And obviously feel free to throw out any others too. So quant comparison. Let me find a good one for that. Quant comparison. Here's a good one. Oops. Classic quant comparison question here. Why don't we do 0 is less than x is less than y is less than 1. And quantity A, 1 minus y. And quantity B is y minus x. Give that one a shot here. And if you're just joining us, I think we might have another person in here. Feel free to introduce yourself. Tell us where you are in your GRE journey. What kind of questions are causing you stress? We're just taking a look at this one right here. Quantitative comparison question. Type your answer in the chat when you have it. cannot be determined, says Mariella. Cannot be determined. All right. Well, we are talking about kind of a limited, very, very limited space. All these numbers are nice and cozy together, right? If we drew this on a number line, there's 0, there's 1, there's x, and there's y, right? So they're all kind of squeezed in there. Now, one kind of important strategy to remember for quantitative comparison, aside from testing numbers, which we can always do, and I hope maybe we did here, right, is that we don't necessarily need to actually know the values, right? Sometimes it's enough to just see a pattern. So we'll kind of go about it the long way first and test out numbers and see what we get. And then we'll kind of look at sort of a broader reason for the answer on this. So go ahead and just give me a value that x could be or y could be. Or actually, x and y could be. Just volunteer a number for x and a number for y, given these constraints. There's always a little bit of a delay on this, by the way, so if you type and you're like, there we go. First tester. Okay, great. So 0.25 for x and 0.5 for y. Totally works within our constraints. 0.5. So 1 minus 0.5 is what? 0.5, right? And 0.5 minus 0.25 gives us that, right? Oh, I think I had this backwards. Okay, great. So in this one particular case, right, in this one particular case, we found that quantity A is greater than quantity B. And so the good news is that allows us to get rid of answer option B and answer option C. I mean, the answer is going to be A or D. And then, of course, what we want to do, as always, is try to break the problem. So Mariella tried to do that by testing two completely different numbers, 0.3 and 0.7. Right there and right there. So in this case, the difference between 1 and y, 1 minus y, is 0.3. And in this case, y minus x is 0.4. Meaning that we have conflicting cases, so the answer is D. Nice work. What did I want to say here? Identifying a subtraction as the difference between numbers is very helpful here. In other words, this is saying, what's the difference between y and 1? And what's the difference between y and x? And of course, since the only limitation that we have is that they have to be in this order, x could be very, very close to 0 and y could be very, very close to 1. Or they could be like right next to each other. There's no limits on what that can be. So correct answer here is, in fact, D. Great. Great, great, great. So we can do another word problem here. Brandy, if even if you have like a particular type, so we could do an average speed work problem. We could do a mixture problem, joint work, parts of a whole, or if there's another topic completely that you want to talk about, we could do a little verbal. Idea of today is just to do some GRE questions. I think I might call this like the GRE gym, where you come to get a workout. A lot of them had more than 2 factors. A lot of A lot of what, Brandy? What were you talking about there? A lot of them had more than two factors. A lot of the word problems? Ah, gotcha. Gotcha. So I'm trying to think of a math word problem with more than two factors. Oh, would this be like a system, maybe? I'm just trying to figure out which types of problems you're referring to here. If not, are you gonna go live on TikTok also? Yeah, I'm gonna do some TikTok lives as well. Um, the issue with TikTok, obviously, and there I know there is a way to do it. I'm still kind of toying around with the tech, but to be able to kind of like, oh yeah, I got you, Brandy. Great. Yes, we'll take a look at that. The issue with TikTok, and I'm exploring kind of streaming technology a little bit. You can simultaneously broadcast to like YouTube and TikTok at the same time. There's a way to do it. Um, but yeah, honestly the TikTok is mostly just going to be like me talking a little bit, not so much solving problems. So and I'll let you know when I am live on TikTok again. But again, it's mostly just going to be me talking about the course and answering general GRE questions. But once I figure out how to do this, solve problems, and cast it to TikTok, I'll let you know that as well. Ideal would be to just have everything streaming at the same time. So 3 different people working on a project at the same at different speeds. How many papers, et cetera, et cetera. Yeah. So let's start with 2 people, and then we'll upgrade to 3. Because with 2 people, there's actually a very straightforward formula that you can memorize. And as you probably know, if you've taken my course or worked with me, like I'm all about understanding like why something is the way it is, rather than just giving you the formula. But this is one case where giving you the formula, I think, is probably the best. Sometimes they give you a value. Yeah. So you tell me, Brandy, if this is the type of question you're thinking of. And again, we'll just start with 2, and then we'll upgrade to 3. So let's say that, John and Bob, or John can eat 12 hot dogs in a minute, and Bill can eat, oh, sorry. This would be something more like this. John can eat let's say John can eat a cake. This is all very appetizing in the morning. Hot dogs and cake. John can eat a cake in 20 minutes. Bill can eat the same cake in 10. How long will it take them to eat a cake if they're doing it at the same time. Is this generally the type of question you're talking about, Brandy? Oh, how many cakes in 2 hours? Yeah, they could ask that. You're saying, like, how many cakes could they eat together in 2 hours? Let's start, because this is like the formulaic way. We'll start with this one, and then we'll answer the question, how many cakes in 2 hours? Because once we figure this out, we'll be able to figure out how many cakes in 2 hours. So the formula, when you have, again, it's a very formulaic question. It comes up quite a bit on the test. When you have two people, a little more difficult. We have 20 cakes already. How many more would we have altogether in 2 hours? Right. Yeah. They throw in little curveballs. So let's start with the basic version of it, and then we'll complicate it a little bit. The basic version of this, where you have one person can do a job in this much time, the other person can do a job in this much time. The formula, and this is just one to know, as much as it pains me to just say that, right? The time that it takes person A times the time that it takes person B divided by the time it takes person A plus the time it takes person B. So in this case, this would be 10 times 20, or 200, divided by 30. Right? And if we use our calculator, that's 20 divided by 3, so 6.66666 minutes. So then going to your other question here, Brandy. Again, we always want to just start with like the basic formulaic way, but then we'll level up a little bit. We want to know how many cakes, we'll start with that first one, how many cakes in 2 hours. So if together they can eat one cake in 6.66 repeating minutes, how many cakes can they eat in 2 hours, Brandy? This is a proportion. Have to use my phone. Oh, don't have a calculator. No worries. What I want to make sure of those that we're okay with proportions. And proportions are a very personal thing, like you could say, right? Because everyone kind of has their own way of doing it. The way that I kind of approach proportions is by saying, and what did you say there? 9 cakes. I'll double check that. So if one cake can be created in 6.66 minutes, how many cakes could I create in 120 minutes? Because that's 2 hours, right? 120 minutes. How many cakes? Well, cross multiplication, right? I do 120 equals 6.66x. And then when I divide that, when I do 120 divided by 6.66, I get 18, just about 18. So 18 cakes in 2 hours. And then 3. Not quite. It's all about setting up that proportion, right? And you don't have to do it this way. If you have a different way of thinking about it, totally fine. But the idea is one cake in 6.66 minutes. how many cakes in 20 minutes? Oh, and I'm having some streaming issues here, I think. You gotta know. Okay. If I cut out, let me know. Oh, there we go. Still okay. Okay, great. Great. So, and then to that other question you had, make it a little more difficult by saying we have 20 cakes already. Solved differently, we got the same answer. As I said, yeah, proportions are a very personal thing. Everyone thinks about them differently because that proportions are something that you use in everyday life, right? And there are, different ways of thinking about it. All right. And so that other question you asked, Brandy, they make it a little more difficult by saying we have 20 cakes in 20 cakes already. How many more would we have altogether in 2 hours? So in that case, it would just be 18 plus the 20 that we already have. Right, 18 cakes plus the 20 that we already have. If you're asking what I think you're asking. But of course, right, there's no shortage to ways that they could ask you about this. They can always just throw a little tweak in there. The classic example, and we don't go too much into this in the class because they're not a huge part of the test, but permutations and combinations. Right? If you're talking about like all the different ways that you can arrange someone in a line, but then there are always these like, conditions like how many different ways could I arrange Alfred, Bob, Charlie, Dan, and Edward in a line? But yeah, Dan's not allowed to stand next to Edward. Right, and I have to figure out all the different ways. So there's always a curveball, but understanding the kind of fundamental formula first is important. It's like playing an instrument. You got to know how to do the scales before you improvise a little bit. Okay. Shall we try another quant comparison question? And if you're joining us, I can't quite tell how many people are in the room at any given time, but if you're just joining us, feel free to introduce yourself. Let us know where you are in your GRE journey. Great. So why don't we look at another quant comparison question? Let's see. There's a good quant comparison. Ooh, this looks fun. Here we go. Oh, but Brandy, we didn't do it with 3 people. Did you want to take a look at that as well? So before we jump over to quant comparison, let's talk about 3-person joint work problems. Because those ones, you got to do a little bit of work. So we'll say we have machine A, machine B, and machine C. Of course. Yeah. Thanks, Marla. Oh, well, Marla's not here anymore. But so we can take a look at these, the 3-parter. Because these ones you can't quite use the formula. So let's say machine A can complete a batch of whatever. Maybe it's a widget making machine. It can complete a batch of widgets in 3 hours. Machine B can complete a batch of widgets in 6 hours. And machine C can complete a batch of widgets in 9 hours. And then the questions, and I'm keeping it simple again at first, and then we can throw some complications into it. The question is, how long to complete a batch if they're all working together? Machines are working together. Okay. So the key to this, and this is actually this comes back to the kind of train problems that we were doing earlier. The key to this is turning these times into rates. And something that the question will always say is that they're working at constant rates. So it's not like it goes fast for a little bit and then slow for a little bit. It's constantly working. So here's the question. If machine A can complete one batch in 3 hours, what fraction of a batch will it complete in 1 hour? If it can complete one whole job in 3 hours, what fraction of the job will it complete in 1 hour? Let's start there. If I have, I don't know, 3 pieces to produce, and it takes me 3 hours, what fraction of the job will I complete in 1 hour? And let me know if you're still there, Brandy. Oh, no worries. So for machine A, the whole job takes 3 hours. So in 1 hour, machine A will have completed what fraction of the job? 1/3 of the job per hour. Right? So 1/3 of the job per hour. The idea here is that we're turning it from a time into a rate. And let me know if that makes sense. Right? The whole job takes 3 hours. So in 1 hour, I'm going to complete 1/3 of that job. Let me know if that's okay, Brandy. Oh, got it. So you're saying I'm a little choppy? Ah, got it. Got it. That's good to know. Okay. Um, I just want to make sure you got this part, Brandy. You can hear every third word. So just want to make sure this is okay. One third of the job per hour. If the whole job takes 3 hours, then every hour I'm going to complete 1/3 of the job. Is that okay? Got it. Okay, great. So then the question is then, what fraction of the job, if machine B takes 6 hours, what fraction is that going to be? If machine takes 6 hours to complete the whole job, what fraction of the job gets done every hour? One-sixth, right? Again, I realize there might be some connection issues, so I'm not sure if you're quite hearing all of this, Brandy. 1/6, right? Yeah. And then, of course, for machine C, it's 1/9 of a job per hour. Well, if machine A can complete 1/3 of the job per hour, and machine B can complete 1/6 of the job per hour, and machine C can complete 1/9 of the job per hour, what's their joint rate? Every hour, so now all the machines are working together. Every hour, machine A is going to get 1/3 of the job done, and machine B is going to get 1/6 of the job done, and machine C is going to get 1/9 of the job done. And I'm going to add those together because this is how much they're going to get done in an hour. Let me know if that's okay, Brandy, or if you can hear me, or if it's all kind of cutting out. But this is my joint rate per hour. And so when I add all these together, what's the common denominator here? 18, right? So this becomes 3 out of 18. Oh, I'm sorry. Huh. Well, tell you what. All right. Got it. Got that. I'm going to finish the explanation, and you should be able to rewatch the live stream after we're done. So I'll finish the explanation here, and then hopefully you can watch this after the fact. So this is 3 out of 18. 2 out of 18. And this is 3 out of 18. And this is 6 out of 18. And when I add this together, 6 plus 9 plus 2, it's 11 out of 18. So they finish 11/18ths of the job every hour. Well, then the question is, the last little question is, if this is their rate, and the distance that they want to go is 1, they want to complete 1 job, then what's the time? Well, rate times time equals distance, right? So it's just 11/18 x equals 1. And then we solve for x. We multiply both sides by 18, divide by 11. So x equals 18 over 11 hours. A little less than 2. 1.75 maybe, somewhere around there. So again, just because it sounds like there were some audio issues, why don't we call it a day there? And I'll type this in. So let's call it a day there. And let me know if you're able to watch our live stream after the fact. Of course, yeah. Thanks for stopping by, and sorry about these audio issues. Hopefully, get these figured out here. All right, take care, everybody. That's it.